Hey everyone, this is Mr. Garcia, and in this lesson I'm going to give you a review on how to graph linear inequalities. So on the previous 3 lessons you learned how to solve systems of equations by using graphs, tables, elimination, and substitution. The next lesson is this one, okay, just as a transition into solving systems of linear inequalities. Okay, so for that you need to be able to remember how to graph inequalities, linear inequalities, so that you're able to successfully learn how to solve systems of linear inequalities. So let's go ahead and get started. A linear inequality is an inequality with 2 variables and a linear boundary line. Solution to an inequality is any point or points that make the inequality true. Okay, so I'm going to give you the steps on how to solve a linear inequality. So step number 1 is you got to solve for y. So your equation has to look like either one of these 4. Okay, step 2, you're gonna graph the line, graph the boundary line. So if you see something like this, okay, or like this, then when you sketch the line, it's gonna be a dashed line for this one. So the line's gonna look like this, something like this. Okay, it might be going up from left to right or down from left to right. If it's less than or equal to or greater than or equal to, then that line is going to be a solid line. So it's going to look like this. I do it or like this, okay? And I should do this one also. Just don't forget that. Step 3, shade the region that represents the inequality, okay? So for that, I'm going to point you to this. If it's less than or equal to, you shade below the line. If it's greater than or equal to, you shade above the line. Okay, so let's go ahead and get started. So in this equation, I see that this inequality is not in either one of these forms. So what I need to do is I need to subtract these 3x's from the left and also from the right. Okay, so then this, I have the 5y by itself greater than or equal to. I'm going to bring the 3x's to the front, and notice that now they're negative. And then I have a 30 with it, okay? So next I'm going to divide by 5, and I'm going to do it to all 3 terms. In the end, I have y is greater than or equal to negative, this is 3 over 5, so that's going to be the slope. So 3 over 5x plus 30 divided by 5 is 6. So this is the inequality that I'm going to graph. So I see that this line is going to have a negative slope, and I also see that the y-intercept is at 6. So I'm going to plot the y-intercept first. So this is 1, 2, 3, 4, 5, 6. And then it has a rise of 3 and a run of 5. So I'm going up 1, 2, 3, and then to the left 1, 2, 3, 4, and 5. I'm going to get one more point from the y-intercept here. I'm going to go down 3. 1, 2, 3, and 1, 2, 3, 4, and 5. Now, notice this is greater than or equal to. So the question is it going to be a dashed line or a solid line? And if you said solid line because you see the equal to, then that's what you do. So next I'm going to sketch the line. Okay, so I'm going to sketch the line of this function, or inequality, I'm sorry. And there is the line, and it's a solid line. Now the next question is, where do we shade? This is saying greater than. Since it says greater than, that means we are going to shade above the line. So I'm going to use a pencil here. So all of this will be shaded. Okay. All right, so next what I'm going to do is I'm going to pick a point not on the line. Okay, so I just want to do this real quick so you can see how this works. So what if I choose the origin? What do you think if I choose this point? Is this point, the coordinates of this point, going to make this inequality a true statement? And if you don't know, you can easily check. So if I choose the point 0, 0, okay, then y is 0 greater than or equal to negative 3 over 5, and x is also 0 here, right at the origin, okay? And then I'm going to add 6. So 0 greater than or equal to negative 3 over 5 times 0 is going to be 0. So all I have left is the 6. Now, is this a true statement? The answer is no, this is not a true statement. This is false. Okay? But if you choose any point on the shaded region, that's going to give you a true statement. So for example, if I choose, let's say 0 and 8, 8 is, so this is 5, 6, 7, 8. This point is on the shaded area. So that should be a true statement if I check. Okay? What about 1 and 7? So if I choose 1, 1 is here. 1, 2, 3, 4, 5, 6, 7. As you can see, that point is also on the shaded region. So that means this will also be a point that we can use. I hope that makes sense. So let's continue to one more example. Okay, I'm going to do one more example on this page. So notice again, I don't have the equation in either one of these forms. Okay, so what I'm going to do is I'm going to isolate the negative 2y. So I'm going to add 12 to both sides of the equation. Okay, so then I have negative 2y is less than negative x plus 12. And let's see if you guys remember what's going to happen here. Next, I'm going to divide by a negative 2 on each term. So then I have y, but now notice x is negative, but it's being divided by a negative. That makes it positive, which means x is going to change sign. It's going to go from being negative to being positive. Okay, so this is going to be 1/2. And then 12 divided by negative 2 is going to be negative or minus 6. Okay, now there is an x here. The slope is 1/2. The y-intercept is 0, negative 6. This is going to get switched. Instead of less than, now it's going to be greater than. Why? Because x went to positive now. It's not negative anymore. Okay, so I hope you guys remember this. So this is the inequality that we are going to graph. All right. Next, I'm going to start with the y-intercept. It's negative 6, 0. I mean 0, negative 6. So that's, let's see, 1, 2, 3, 4, 5, and 6. 0, negative 6. And then this has a rise of 1 and a run of 2. So up 1 over 2. Okay, up 1 over 2. And I'm just going to get 3 points because that's going to be enough. Now for this, again, I'm going to use a straight edge. I'm using my ID here. Next question is, this is greater than. So is that going to be a solid or dashed line? And if you said it's going to be dashed because it's not equal to, you're correct. Okay, so I'm going to draw a dashed line here. And there is the line that represents this inequality. Next, this is saying greater than. So where do I shade? And if you said above the line, you are correct. So all of this is going to get shaded. Okay, and we're just going to choose a couple of points here that are on the shaded area. And they should make this a true statement. Okay, so what if we choose 0 and 8? What do you think? Does that work? Okay, 0 and 8, it's 0 is here, 8 is way up here. So that should make it a true statement. What about 1, 1? That point is here, also in the shaded area. Well, let's choose one more. Let's say 10 and 10. So we know 10 is going to be on the shaded area. So these points should make this a true statement, okay? But if we choose any point here on the area that's not shaded, it's going to give you a false statement here. All right, so if you're okay with this, you don't have to do the second part of the lesson, but I'm going to go to the second part in case you still don't remember this, okay? So I'm going to flip to the next page. And then here, I'm just going to graph, okay? I'm not going to do everything that I did on the previous page for the sake of time. So again, first I'm going to solve for y. I'm going to subtract this 3 from both sides of the equation. Okay, so then I have negative y less than negative 5x minus 3. And again, I have a negative y. I don't want negative y. I want positive y. So I'm going to divide by negative 1 on each one of the terms. So then y, and watch here, this is negative, being divided by negative is going to turn that 5x into a positive 5x. And then negative 3 divided by negative 1 becomes plus 3. And this gets switched. Okay? So then I'm going to graph this inequality. So the y-intercept is 0, 3, 1, 2, and 3. And then this one has a rise of 5 and a run of 1. Okay, so 1, 2, 3, 4, 5. And 1 to the right. If I go down 1, 2, 3, 4, 5. 1 to the left. And now this is not equal to, so that means I'm going to do a dashed line. Okay. So there is the dashed line. And now the shade part, we're shading, this is greater than, so greater than means all the values here. So all of this is going to get shaded. All right, so there is that problem. Let's go on to the next one. Okay, the next problem is we need to isolate the y, so I'm going to subtract these 10 x's from the left. So then I have 8y less than or equal to negative 10x plus 64. Next, I'm going to divide by 8. So then y, this is not going to change sign, so I'm not going to change this symbol here, okay? So it's going to say as less than or equal to, but 10 over 8 simplifies to 5 over 4, and it's going to be negative, right? So there is the slope, and then 68 divided by 8, that's 8. So this is the inequality that we're going to graph. All right, so let's start with the y-intercept. So it's 1, 2, 3, 4, 5, 6, 7, and 8. 0, 8, that's, those are the coordinates of the y-intercept. And from here, this has a rise of 5 and a run of 4. So I'm going to go down because I don't have any space to go up. So 1, 2, 3, 4, 5, and the slope is negative. So 1, 2, 3, 4. I need to go left. All right, I'm going to get one more point. 1, 2, 3, 4, 5, 1, 2, 3, and 4. Next, this is equal to, so this line is going to be solid or dashed. And if you said solid, you are correct. Okay, so I'm going to connect the points. I'm going to sketch the line. And this is the line that represents that inequality. All right, this is less than, which means I'm going to shade below the line. So this is below, so all of this gets shaded. Okay, I hope this helped you remember how to graph linear inequalities. Thank you for watching. I'll talk to you soon. Bye-bye.